year, you might have studied about the classification of elements and the periodic properties, right? So we have discussed, so what is discussed there? So as we cannot study each element individually, okay? So what we are studying the elements in a particular group, okay? So we are studying in terms of the group. So based on the group, so they are divided into 4 groups, right? So S block, P block, D block, and F block elements. So as we cannot study, so there are 118 elements, right? So as we cannot study each element individually, so these elements are grouped, okay? They are arranged in the increasing atomic number, okay? And they are placed under, they are, so the elements which are what they are occupying the same group, they are following the same group, they are placed under same groups, okay? And they are divided into 4 groups, that is S block, P block, D and F block. So this you have studied in the PUC 1, okay? That is classification of elements, as well as you have studied the periodic properties. They are periodic properties, how the different periodic variations takes place, okay? How the atomic radii vary, okay? What is ionization enthalpy? What is electron gain enthalpy? What is electronegativity? Okay, so these are the things which are related to their periodic properties, okay? The variations across the period down the group. So these all things you have studied in the first year. Okay, then in the first year you have also studied what? So yes, S block and P block is deleted from. Okay. So previously, okay, in the first year, the chapters like S block elements and P block elements, okay, and hydrogen. So hydrogen was the element, okay, hydrogen is an element, so which is studied separately as a lesson, okay? So we had a lesson called hydrogen, as well as S block and P block elements. So there, particularly in the groups, we had to study about the S block elements and P block elements. So as it is deleted, okay, so that was not taught for you all in the previous year. Okay. Uh, in chemistry, okay, so there are as per this, so there are 16, okay? So like from the old syllabus, you have 16 chapters. So there are 6 chapters directly deleted. Okay, so we like now D and F block elements you have completely. Okay, so whatever the chapters are taken, so 10 chapters you have. Okay, you have 10 chapters for PUC second year. So from that again, nothing else is deleted. So directly 6 chapters are deleted. So how? So in the first year, S block and P block was there, but it is deleted from your syllabus. So directly you are going to study about D and F block elements. Okay. So S block elements. So I'll just give you a brief idea about that. So S block elements are what? S block elements, they comprise of group 1 and group 2 elements, okay? That is alkali and alkaline earth metals. Then P block elements. So P block element, it starts from group what? Group 13, okay? Group 13 to group 18, right? 13, 14, 15, 16, 17, 18. So this 6 groups, they come under P block elements. So in the first year, you had 4 groups and 3 groups, and in the second year 3 groups, but it is deleted from the portion, okay? So it is deleted. So directly you are going to discuss about D and F block elements. Now what are these D block elements? Okay, so we'll start with the D block elements. How is the placement of this D block elements? Okay, let me tell you. So if you see the periodic table, okay, if you see the periodic table, so suppose this is a periodic table. So to your left hand side, you have your S block elements. To your right hand side, you have your P block elements. Okay, in the center, you have your D block elements, your F block elements. Now, so we are going to start with the D block elements. So these D block elements, they are the elements which are partially filled d subshell in their atomic or ionic radius. Okay. So the last element, if it enters into the, if the last electron of the element, if it enters into the d subshell, okay, in their atomic or the ionic state, then they are termed as what? D block elements. So this is about your D block elements. So what is D block elements? So D block elements, they are defined as the elements which are having partially filled, okay, D subshells in their atomic or ionic radii. Then okay, then so these, in this elements, okay, in this D block elements, what will happen? The electron, okay, the electron of any element, okay, it will get filled in the penultimate shell. What do you mean by penultimate shell? Into the last but least shell. Okay, so into the D last, that is, it enters into the D subshell, and what happens? It gradually gets filled with electrons. Okay, so the general electronic configuration. So what is the general electronic configuration of this D block elements? It is n minus 1. Okay, n minus 1, D 1 to 10, and ns 1 to 2. So this n minus 1 means what? This is your penultimate shell. It is called as penultimate shell. So 1 mark this is important. So what is the general electronic configuration of D block element? That is n to 2. Okay, so this is your general electronic configuration of D block element. Then, so in this D block elements, there are 4 groups. So how many groups there are? Okay, so there are 4 groups. So there are 4 groups. Okay, in the D block elements, or you can say there are 4 series, you can call it. Okay, you can call it as 4 series of D block elements, Okay, so the 4 series are 3D series. Okay, it starts from scandium to zinc. Okay, then is your 4D series. Okay, it starts from chromium to cadmium. Okay, then is your, sorry, not chromium, it is yttrium. Okay, yttrium to cadmium. Then is your 5D series. 5D series, it starts from lanthanum to mercury. Okay, and then is your 6D series, which begins with actinoids. Okay, so what happens? So if the electrons, it starts filling into the 3D series, okay, then they are said to be 3D orbitals. Okay, so it enters into the 3D orbitals. Then if the electrons of these elements, if it enters into the 4D series, so they are termed into the 4D orbitals. Okay, so like this, eventually the filling of electron takes place. So these are the 4 series. Now this 6D series, okay, 6D series, it is incomplete series. Okay, it is incomplete series. So we have not mentioned from where to where the 6D it starts and end. Okay, so this is about the 4 important series of D block elements. So please remember the what your general electronic configuration. So this is the general electronic configuration. Okay. So here is the general electronic configuration, important. And then what are the 4 series of D block element? Okay. So now we are going to see the general properties. Okay. What are the general properties of D block elements? Okay. So what are the general properties? These D block elements, okay, so these D block elements, they are also called as D block elements. They are also termed as what? They are also termed as what? Transition elements. So please remember this. So what are D block elements? the D block elements, they are termed as what? Transition elements. Okay. And these elements, where they are placed? They are placed in between that of the S block elements and the P block elements. So they are placed in between that of the S block and P block. So in the center, these D block elements are placed. Okay. So these are called as transition and where they are placed. So this is the placement of the D block elements. Then when we see the first general property is the physical properties. So we are going to see the physical properties of D block elements. Okay. So the first physical property is that these transition elements, okay, these transition elements, they show high tensile strength. Okay, what do you mean by high tensile strength? Yes, what do you mean by high tensile strength? They have the what? It cannot be what you can say. It has a very high strength. Okay, it has a very high strength. You cannot break it, or you cannot suppose you cannot cut it or anything like that. Okay, so it is having a very high tensile strength. So the strength is very much high. Okay, of the D block element. So that is the transition elements. Then they are having the property of ductility. It has a property of showing ductility and malleability. Can anyone tell me what do you mean by ductility and malleability? Yes, what do you mean by ductility and malleability? Anybody? What do you mean by ductility and malleability?
Which can go on thick wire.
Yes, which can be converted into thin wire, and malleability. Yes,
Thin sheet.
into thin sheets. Okay, so into thin sheets and thin wires. So this is the unique properties, okay, which are shown by the metals. So transition metals, okay, they are having high tensile strength. So it is having a very good strength. Then they have the property of ductility, that is, it can be converted into thin wires, and malleability, that is, it can be converted into thin sheets. Okay. Then they are highly thermal. Okay, they are high thermal and electrical conductivity. They have a high thermal and electrical conductivity. Okay, they are having high thermal and electrical conductivity. So means what? They are highly stable towards heat and electricity. Okay, so unlike the properties of metals, so transition metals are also having that unique property. Okay, that is, they are having very resistance. They are very resistive. They are having a very high resistivity towards the thermal and electrical conductivity. Okay, so these are some of the important properties of transition elements. So some other properties, like they form stable complexes. Okay, so whatever the compounds of the that is the compounds complexes are formed from this transition element, they are stable. Okay, they are stable. So it can form a stable complexes. Then these are transition elements. They are having high melting and boiling point. Okay, because of the high tensile strength, okay, because of the higher strength, so it cannot be broken easily. It cannot be beaten easily. So because of that, it is what is that? The forces are stronger. Okay, the forces are stronger between these metals. So because of that, it is having high melting and boiling point. Then these compounds, okay, they are often paramagnetic. Yes. Can you tell me what do you mean by paramagnetic now? What do you mean by paramagnetic? So whatever the transition elements, they are forming the compounds. Okay, and these compounds are often paramagnetic in nature. What do you mean by paramagnetic in nature? Paramagnetic, it is a magnetic
Only
behavior.
one element.
Only?
One element is present.
No. It is a magnetic behavior. Okay, paramagnetic. Paramagnetic means what? Okay, so these are weakly, or you can say they are weakly attracted by They are weakly attracted by externally applied magnetic field. Okay, applied magnetic field. So this is the meaning of paramagnetic. Now suppose, okay, suppose what happens? Okay, so these are weakly attracted. How it will be attracted? Suppose you have a unpaired electrons. Okay, now when you are seeing the electron, so some of the electrons will be paired. Suppose I have a d5 system. Okay, I'll write the d5 system. Now, maximum number of electrons occupied, or how many what is that? Maximum number of electrons which can be, or which are placed in d block are how many? How many electrons can be accommodated in d block elements?
5. 5.
5.
10.
Yes, it is 10. Okay. So in S block, how many electrons? Maximum number, it is 2.
2.
Okay. Yes, in S block, it is 2. Then P block, 6.
6.
Right. Yes, it is 6. Then in D block, it is 10. And F block?
14.
14.
14. Yes, yes, good. Okay. So maximum number of electron which can be accommodated in the d orbital is 10. Suppose I take a d5 system. Okay, I take a d5 system. So how will I feel the electrons? Yes. So in the first year, we have studied Aufbau principle. Okay, we have studied Hund's rule of multiplicity. Right. So these are the rules which we have studied. Okay. So by applying these rules or these principles, we know that the electron filling, okay, first it will be done singly and then the pairing will takes place. Right. Now we have a d5 system. So d5 means what? There are 5 blocks, right? So what I'll do, that in the each orbital, I'm going to add 1 electron. So if I had a d6 system, what will happen? Then the electron would get paired here, right? d6 system. But I have now only how many? d5. So single system. So now what you can see here, there are 5 unpaired electrons. Okay, there are 5 unpaired. They are not paired. They are unpaired, right? So there are 5 unpaired electrons. Now these 5 unpaired electrons, what will happen? They will get weakly attracted by externally applied magnetic field. Okay, so because of the presence of this unpaired electron, okay, they are said to be paramagnetic in nature. They are said to be what? Paramagnetic in nature. Now, suppose, okay, now suppose I have a D10 system. I have a D10 system. So what will happen? First, the electrons will fill singly and then the pairing will takes place, right? Now here, so what happens here? All the electrons are paired. All the electrons are paired. So what type of magnetic behavior it will show? It will show diamagnetic. Yes, it will show diamagnetic behavior. Now, what do you mean by diamagnetic behavior? In diamagnetic behavior, it is repelled. Okay, it is repelled by a magnetic external magnetic field. Okay, so when the external magnetic field is removed, it is repelled. Okay, so it shows diamagnetic. So why diamagnetic behavior is shown by which compounds? Which are paired. Okay, there is no unpaired electron. All the electrons are paired. Then such a system is called as diamagnetic. Now, when there are presence of unpaired electron, if there is one unpaired electron also, then it will have a then it will show what? Paramagnetic in nature. So most of the transition elements, okay, the compounds which are formed by them, they are often paramagnetic in nature. Then also they are hard. Why they are hard? Because of the high tensile strength. Okay, and because they are hard, they are having high density. Okay, they are having high density. Then they form compounds with catalytic activity. What do you mean by catalytic activity? So whatever the transition elements are there, So these transition elements which forms the compounds, okay, they are having a, they show catalytic activity. Okay, they will enhance the or they will increase the rate of activation. Okay, so the reactions takes place at a speedy rate. Okay, it will takes place at a very fast rate. Okay, so this is without altering the rate of reaction. So this is your catalytic activity. So most of the transition elements, okay, they form the compounds and they are having what? They are showing the catalytic activity. Then they show variable oxidation state. Now, what do you mean by variable oxidation state? Okay, they will show different type of oxidations. Okay, suppose Fe. Fe will exist in +2 as well as +3. Okay, so nickel. Okay, nickel will be always in +2. Then your cobalt will be +3. Okay, so like this. Then zinc +2, copper +2. Okay, copper +1. Okay, copper will be so like this. So different elements. Okay, Mn. So Mn can exhibit in what? +2, +5, +7. Okay, so these are the different oxidation state. Okay, so the transition metals, they will show, okay, transition metals, what they will show? They will show the uh, uh, transition metals, what they'll show? They will show the variable oxidation state. Variable means what? Different oxidation state. Okay, so they will exhibit in different oxidation state. Then these transition elements, they have also the unique property of forming colored complexes. Okay, the colored compound. So what they will do? What they will form? So the transition elements, they will form the complexes which are colored in nature. Okay, they are colored in nature. So whatever the compounds are formed, they form colored ions and compounds. Okay. What do you mean by catalytic activity? So just now I told you what do you mean by catalytic activity? Catalyst. Okay. What is the role of a catalyst? Suppose a reaction is going on. Okay. Suppose the reaction is going on. Now, instead of okay, so whatever the reactant, so how the reaction will proceed? So A plus B will give you C plus D. Okay, suppose this is a reaction. Now to for the reactants to react, okay, so these are termed as reactants and these are termed as products. Now these reactants will react with each other, okay, and they will give you the product. Now to react this reactant and to convert it into product, it will require some time, right? It will take some time for the conversion. Suppose this reaction is taking for 3 hours. Suppose this reaction is taking place for 3 hours. Now, the same reaction, okay, the same reaction again, A plus B giving you C plus D, okay, takes place in the presence of this catalyst in 1.5 hours. Okay, so what is happening? Okay, what you can see here, what is observed? See, if we plot the graph for the same, okay, so so for the reaction A plus B giving you C plus D, the reaction will proceed at a 3 hours. Okay, it will take 3 hours time. Okay, it will take what? 3 hours time. Then for the reaction, suppose this is your first reaction. Okay, then for the reaction, so this is our first one. This I have taken first one, then second one. Then this will undergo in the presence of what? In the presence of a catalyst. So it will take how much? It will take the same. Okay, they have formed the same product, C plus D. So from A plus B, it is giving you C plus D. But this is okay, this is without catalyst and this is in the presence of catalyst. Now, what is the role of this catalyst? Okay, so what is the role of the catalyst? So catalyst, it will activate the okay, it will what it will do? Catalyst, okay, it will it will increase the rate of reaction. Okay, it will increase the rate of reaction without altering any changes. Okay, so it will fasten the rate of reaction. Whatever the speed at, so it was going to take place for 3 hours, right? The rate of reaction was going to take place in 3 hours, but in the presence of catalyst, what it is done, it has taken place in 1.5 hours. So what is done? So the this chemical reaction, so the rate of chemical reaction is increased. Okay, so this increase in rate of reaction, okay, it is nothing but it is called as the catalytic activity. So the activity which is shown, okay, the increase in rate of reaction, it is shown by the catalyst. So this is called as catalytic activity. So different transition elements. So there are different transition elements which are used as a catalyst. Okay, so it will enhance the rate of reaction. It will fasten the rate of reaction without changing any equilibrium or anything. Okay, so only the time, okay, the rate of reaction is increased. Okay, the speed of the rate of reaction is increased. So these so this is the, it changes the rate of reaction. Only thing is what, it will take a different path. Okay, it will take a different path and it will require very less amount of energy. So instead of 3 hours, it will be done in 1.5 hours. So this is called as catalytic activity. So catalytic activity, it is shown by the catalyst. Okay, it is shown by the catalyst. So different transition elements, there are different transition elements which will form the compounds. Okay, and they will have this unique behavior or unique property of catalytic activity. So these are some of the general properties of transition elements. Okay, so these transition elements, okay, they form colored complexes. They are colored complexes. Okay. Then also we have discussed here, they are having high melting point and boiling point. Okay, why high melting point and boiling point? I have discussed just now, because they are intermolecular forces. Okay, intermolecular bonding will be more. So if the intermolecular forces between the metals are more, then to break the bond, to break the forces, it requires high amount of energy. Thus, it will result into high melting and high boiling point. Okay, so these are some of the general properties of what, d block elements. Okay, let us move for the next one. Next is metallic character. Okay, so metallic character, all the d block elements, they are metals. Okay, so generally all the d block elements, they are what, these are all metals, as the number of electrons in the outermost shell are 1 or 2. So in d block elements, the number of electrons in their outermost shell, so the outermost shell is what, the last orbital, okay, in which the number of electrons present, they might be either 1 or 2. Okay, then the metallic character of these elements, okay, so they are hard, as we have discussed transition metals, okay, these are generally hard. Why? Because they are having high tensile strength, right? Then these, as they are metals, as you know, all the metals are hard, they are malleable, they are ductile, okay, except mercury, all the other metals or other transition metals, they are hard, malleable, and ductile. They have the unique property of, okay, getting converted into thin wires and getting transformed into thin sheets. Okay, then 1b group elements, that is copper, this gold and silver and gold are most ductile and soft. So the copper and your silver and gold, okay, so these are most ductile and soft. So you know that gold is very soft. So these are some of the behavior or characters of the metals. Okay, then these are good conductors of heat and electricity. So why metals are good conductors of heat and electricity? Due to the presence of free electrons. Okay, So due to the presence of free electrons, they are having or they show good conductors, or they behave as a good conductor of heat and electricity. Then the elements of 1b group are most conductive in nature. So they are conductive in nature. So what is the order of their conductivity? So Ag is greater than copper, is greater than Au, is greater than Al. So this is the order of conductivity. So this is the metallic character. Okay. So as they are most conductive in nature, so this is their order. Then when you are discussing about the bonding, okay, so these elements, they are having covalent and metallic bonding. Okay, so they both exist. Okay, so the elements, they can show both covalent as well as metallic bonding in the atom of transition metals. So all these transition metals, okay, they show covalent as well as metallic bonding. Then the presence of partially filled d subshell. So the partially filled d subshells favor covalent bonding. So if the electrons are filled partially means what? If they are not filled completely. Okay, if the electrons, d block elements, if the d orbitals is not completely filled, if it is half filled, or if it is okay, partially filled, then it will favor covalent bonding and metallic bonding. These bondings are favorable only due to position of 1 or 2 electrons in outermost energy cell. Okay, so if only 1 or 2 electrons are it is filled, okay, then what will happen? So this type of bonding takes place. So because of this, so these are some of the characteristics or of some metals. Okay, so these are the characteristics of the transition metals. Okay, next is the reducing power. Okay, now what do you mean by reducing power? So reducing power of a d block elements, it depends on what? It depends on their electrode potential. Okay, so so there is a series of elements. So the series of metals. Okay, so these series of metals, they are arranged in their increasing order. They are increased in their increasing order of their standard hydrogen electrode potential. So based on that, their reducing power is denoted. Okay, so reducing power of d block element, it depends on that electrode potential. So standard oxidation potential of copper. So if you see that series, so the standard oxidation.
What is reducing power, ma'am?
That only I'm explaining.
Okay.
Okay, so it depends on the electrode potential. Okay, now there is a series that is hydrogen. Okay, standard electrode series. Okay, standard reducing potential series. So when you see the standard electrode potential series of the elements, okay, it tells you what is the reducing power. Okay, now so how it tells you about the reducing power? So how the elements will reduce? Now you know what is oxidation, what is reduction. Okay, so what is oxidation? Oxidation is nothing but addition of oxygen. Okay, addition of oxygen or removal of hydrogen. Fine. Now same way, what is reduction? Okay, reduction is addition of hydrogen and removal of oxygen. Fine. So here what will happen? So when similarly, when the reactions are going, okay, in one reaction, one of the reactants, they are undergoing reduction, another is undergoing oxidation, then they are termed something called as redox reaction. So in redox reaction, what is happening? The elements, okay, the what is that? The metals or the compounds, they will simultaneously undergo oxidation and reduction. Okay, now what is happening here? So one of the element, okay, so the whose reducing power is minimum. Okay, so here when we are seeing that AU. Okay, AU is the, that is gold is the least reducing element in the D block element because of their positive value of standard that is standard reduction potential. So when you see the series, okay, it tells you how it reduces the this what elements, that is the D block elements. So this reducing power, okay, it completely depends on what? It completely depends on this your standard reduction potential. So when you see the standard reduction potential of the elements, okay, so it is given in the textbook. I'll give you the series. So that time, okay, so here, so let us see the hydrogen, just a second, standard potentials. Okay, so different values are given. For example, for F2. So for F2 to fluoride minus, the value is 2.87. Okay, like this for water. Okay, that is H2O2 to H2O. Okay, so the ability of reduction here. So it will be what? 1.78. Then like this, the different series are given for H plus. Okay, that is 2H plus giving you 2, that is H2, it is 0. So like this, the different E naught values are given. So this is the standard reduction potential values. Okay, it tells you how the species is reduced. As I've told you, so one has the ability to reduce and another will undergo oxidation. Now what is as we are mentioning you about reducing power means what? It will reduce other and itself undergo oxidation. Okay, so whatever the element, now suppose I have what, I'll take an example of Fe. Suppose I have Fe and copper. Okay, take for example, or take ZnSO4 and copper. Should I take ZnSO4 and copper chloride? You take. Okay, so what you are going to obtain here? You are going to obtain
Zinc chloride,
Zn
copper sulfate.
plus copper sulfate. Now what, so which is when you see the reduction potential series, okay, when you see the reduction potential series, zinc, okay, so zinc is what? Zinc is having minus 0.76. So this is the E naught value, and Fe is having minus 0.44. Okay, so what will happen? It so the zinc, so zinc is getting replaced by copper. Why? Because the standard electrode potential value of zinc is more as compared to that of copper. Okay, so like this, so when we are comparing, so copper is having copper is having plus, okay, copper is having plus 0.34, plus 0.34. So minus values, what it indicates? Minus values, it indicates that it is more reducing. Okay, it can be it acts as a reducing, it has the ability to reduce other, and plus means it is having a least value. So copper is having the least value, you can see it is having a minimum value, so it cannot reduce, so it is said to be a least reducing element in 3D series. So what is the reducing power? Reducing power means it reduces other and itself undergoes oxidation. So the reducing power of this D block element, it depends on what? It depends on this standard hydrogen electrode values. Okay, so standard hydrogen electrode values for all the elements is given different. Okay, So depending upon the value, so minus values. So whenever you have minus values, so those that means it is a good reducing agent. Okay, if you have a plus value, then it is a least reducing agent. So this tells you the reducing power of the element. So when we are discussing about the reducing power, so we have to come into consideration about the electrode potential values. So the poor reducing capacity of the transition metal, okay, it is due to why? It is due to high heat of vaporization, high ionization potential, low heat of hydration, and their ions. Because reduction potential depends on all these three factors. What do you mean by ionization potential or ionization enthalpy, right? So this we have discussed, this you might have studied in the first year also, ionization potential. Okay, it is the minimum amount of energy which is required by the electron. Okay, it is the minimum amount of energy required by the electron to by the element to remove the electron from its isolated gaseous atom. Okay, so the minimum amount of energy, whatever the minimum amount of energy which is required, okay, to remove the electron from the isolated gaseous atom, okay, that is your ionization enthalpy. So if the ionization enthalpy is high, okay, then so these are the three factors which are responsible for the poor reducing capacity. So if the transition element, if it is having high heat of vaporization, if it is having high ionization potential, if the minimum that is the energy required, if it is more, okay, then it is very difficult, or it will not show the reducing power. Okay, so these are the three factors based on what the reduction potential is dependent of the transition metal. So just remember, okay, not so important about reducing power, but what you have to remember that reducing power, it depends on the standard electrode potentials of the different metals, okay, or different elements. Fine. Now here, when we are discussing about reducing power, so reducing power, it tells you about how is the reducing capacity of that particular element. Okay, if the negative charge is there, if the values are in negative, that means it is having good reducing power, and if you're having a positive sign, that means they are least. Okay, so these are some of the important points from reducing power. Next is the density. Okay, now the atomic volume of the transition elements are low as compared to S block elements, because density is comparatively high. Because when we see the volume, okay, atomic volume is low. Why? Because density is equals to mass by volume. So if density is high, volume will be obviously low. Okay. So as compared to your S block elements, your density volume is low, because density is given as osmium and iridium is having what? These are having highest density. Okay, in all the groups there is a normal size in increase in density from 3D to 4D series. So when you see the variation of density, okay, so there is normal increase. So when you see the increase in the density, that is from 3D to 4D series, so there is normal increase of density. From 4D to 5D, it increases just by double. So from 3D to 4D, there is normal increase, but when you see the increase from 4D to 5D, there is double. Okay, so the mass, that is the density, increases double. Why? What is the reason? It is due to lanthanide contraction. So about lanthanide contraction, we are going to discuss, okay, in our next class. So just remember why, when we are moving from 3D to 4D series, what is happening to the density? It is increasing. Okay, it is increasing slightly, it is going on increasing. But when we are moving for 4D to 5D, what is happening to the density? It is directly doubling. Okay, it is getting doubled. What is the reason? The reason is lanthanide contraction. So this lanthanide contraction we are going to discuss in the next class. Okay. So after that, so that is a very important concept, lanthanide contraction. So that I'll take in the next class. So now here we'll discuss boiling point. Okay, and then this stop. Fine. So next is melting point and boiling point. As if you plot the graph, okay, if you plot a graph of, okay, now here, if I take a graph, okay, so this is of melting point and I take your atomic number, okay, so hafnium, okay. So I'm just writing the series, okay. Chromium, manganese, Fe, cobalt, nickel, and copper. Okay, and nickel and copper. Copper comes here. Palladium and Ag and platinum and your, just a second. I'll do it properly. So copper. Then this goes here Ag. And this goes here is Au. Okay. Fine. So let me draw here. So atomic number. So like this is the graph. From this graph, okay. Now from this graph, what you can see that in any row, okay, you can see that the 1, 2, 3, 4, 5. Okay. So at this Mn, where is Mn? Okay, here Mn this. Okay. Except Mn and Tc. So you can see in any row, okay, that is your 3D series, 4D series, 5D and 6D series. Okay, we have plotted. So I have plotted 3D, 4D and 5D here. Now here, what you can see that when you are seeing the melting point, okay, the melting point will be maximum at D5. So at the D5 series, okay, for D5, that is your manganese, then your technetium, okay, then you are here. So here you can see that the melting point is maximum. So when you are seeing, but except for manganese, what melting point is not maximum there. What is happening here? So slowly you can see that the melting point is increasing. Okay, it is increasing gradually as there is increasing atomic number. So as the atomic number is increasing, so you can see slowly from titanium, okay, to chromium, then again from here, what is that? Fe, cobalt. Okay, so what is happening to that? This melting point in the maximum cases that it is increasing. So it increases with the increasing atomic number. Okay. Now the metals only these are the exceptions. So here is only the exception where the what is that? Your melting point is falling. But in the most of the cases, as the atomic number is increasing, as you're moving from left to right, okay, what is happening to melting point? Melting point is also increasing. Now the metals of the second and third series, okay, you can see the metals of the second and third series, okay, they are having higher melting point as compared to the first series. Okay, so these are the first series, these are the second series, and these are the third series. So when you're comparing the third and second series, okay, they are having higher melting point as compared to that of the first series. Okay, now, why this is what is the reason for that? Yes, what is the reason? You can see that the atoms and ions, okay, they are having what is happening? There is decrease in the radius, okay. As you are as you go, okay, as you go down the series, what is happening? Okay, there is a decrease in the radius with increase in atomic number. Okay, so when you see in D block elements, okay, as you are seeing, what is happening? You are adding electrons. Okay, as you're moving, as there is increase in the atomic number, what is happening? You are adding new, addition of electrons takes place. Okay, addition of electrons will takes place into the D subshell. Okay, so as you are moving from this, okay, from zirconium to Nb to molybdenum, okay, technetium, ruthenium. So what is happening there? So addition of electron takes place. Okay, so as the electrons are having same charge, okay, the elements are having same charge. So what will happen? There will be decrease in the radius with increase in the atomic number, because the electrons are adding in the same subshell. Okay, and this effect, so you know that effect, this effect is called as what? Shielding effect. Okay, shielding effect. What is shielding effect? Now in the center, what is present? Protons are present. Okay, now protons, then what is there? The orbits are there. Now different electrons, so s electrons. Okay, then there will be 2 electrons. Then what happens? Then there will be s1 s2 2 s2 2p6 6 7 8. Then comes your 8 electrons, right? 3 4 5 6. Now when you want to remove the, so subsequently addition of new electron takes place at what? At the outer orbit. At the outer orbit, as you are moving from left to right, the addition of electron takes place at the outer orbit. Now what will happen? The electrons will put the maximum force to attract the electrons from the outermost shell. Okay, and this that is the force which is applied by the protons on the outermost electrons. Okay, that is called as what? It is called as the shielding effect. Okay, so what is happening? Whatever the electrons are entered from the outermost shell, okay, the nuclear force of attraction, okay, there is a nuclear force of attraction. So the nucleus is showing the force of attraction and shielding effect. So it's is increasing. Okay, so from left to right, the electrons are added in shell. What is happening? The nuclear force of attraction shielding here. Yes, is this clear? So shielding effect is important. You might have studied this in the this also classification of elements about shielding effect. Okay. So is it clear up to here? Okay. Others? Oh, okay. What I'll do, I'll explain again about the shielding effect in the next class. Okay. So already it is time up. So I'll explain this in the next class. Fine. Anybody else have not understood anything else? Yes, apart from shielding effect. So the last part I'll be discussing again once in the next class. Okay. So anything else you want me to explain? Okay, fine. So I'll end the session here. Yes, so we'll meet in the next class. Thank you. So please read once. Okay, whatever has been taught today, please read it once. Whatever, if you have not understood anything, we'll get back to you tomorrow again. Okay, so whatever the doubts are, please clear there and there itself. Fine. Okay. Okay. Fine. Thank you. So I'll end the session here. We'll meet in the next class.